Hello, dear friends of the American Concrete Institute. My name is Carlos Thomas and I am researcher at the Laboratory of Materials of the University of Cantabria in Spain. First of all, I want to thank the American Concrete Institute for the opportunity that brings us to present this research project. The work that I'm going to present you is entitled Siderurgical Aggregates as Alternative for Structural and High-Performance Concrete. This is part of a PhD research project, a doctoral thesis. In this work, I'm going to show you the introduction and the objectives of this project, the state of the art around the siderurgical aggregates and the siderurgical wastes, the materials and the methodology followed for the characterization of these materials, the results and the analysis of them, and finally the conclusions and the future lines of research around this topic. In Europe, more than 4 million tons of electric arc furnace slag are produced every year, and they are not used in any application. The ending up of these wastes is landfill. One of the main challenges of our society is to research in new sustainable building materials. We have to focus on the recycling of construction and demolition waste, but also industrial wastes. The recycling of siderurgical slags in order to produce concrete is one of the most interesting parts of the circular economy around the construction, because it prevents the ending up of these wastes in landfills, also reduce the destruction of natural resources, save in CO2 emissions, and also reduce economic costs. So we are planning to take a siderurgical waste, the electric arc furnace slag, and we are going to produce a siderurgical aggregate, a new aggregate to produce new concrete, more environmental friendly concrete. So first, we are going to determine the properties of these siderurgical aggregates. What are the main properties? First, the high density. The typical density of a siderurgical aggregate is higher than 3 grams by cubic centimeters, but it presents high strength, also high toughness, and excellent mechanical durability. The shape of this material is very interesting in order to increase the bond between the aggregate and the cement paste. Also, depending on the method to produce the siderurgical aggregates, it can be present porosity and also sometimes heavy metal leaching. What are the potential applications in which we can use the siderurgical aggregates? Due to the high density and the excellent mechanical and durability properties, we can use them in prestressed beams. Also, due to the high density in applications in which the high density is a good point, for example, for radiation shieldings, for example, for precast impact barriers, for weights, and also for breakwater structures. Where and how are the electric arc furnace slag produced? In the electric arc furnace, we produce steel, and the slag, the waste that it is produced, is a consequence of the production of the steel. So, in this case, we can say that it is a byproduct. After obtaining the slag from the electric arc furnace, we try to cool the slag slowly, because with the slow cooling, we obtain a crystalline structure of this material in order to prevent the reactivity of the material after using it in concrete. After the cooling, sometimes it is necessary to crush the material and sieve in order to obtain the grading that it is necessary to produce the siderurgical aggregate in order to produce concrete with it. So, What are the main properties of the siderurgical aggregate concrete? We have to take into account, firstly, that the siderurgical aggregate presents a lack of fineness, and it supposes that we have to incorporate extra sand to close the aggregate skeleton. But also the use of siderurgical aggregates improve the IT of the material, in this case, especially the bond between the cement paste and the aggregate. Regarding the physical properties, of course, the use of siderurgical aggregate increases the density of the material if we compare it with the density of the standard concrete. And also, it presents higher porosity and absorption, but it is due because the volume of cement paste sometimes is higher in the siderurgical aggregate concrete because the cavernosity of the siderurgical aggregate doesn't close the volume very well. But the mechanical properties of the concrete performed with siderurgical aggregate are much higher than the compressive strength, for example, of the standard concrete using natural aggregates. Also, the elastic modulus, the Young modulus, is higher in this case because the higher elastic modulus of the aggregates. What about the durability? If you analyze the bibliography, nowadays there is a controversy between the results obtained by different authors. But in this experimental project, we have demonstrated that the durability of the siderurgical aggregate concrete is as good as the durability of the standard concrete. One of the main objectives of this research project is to obtain a concrete for radiation shielding. There are two ionizing radiation very dangerous for humans. One of them is the gamma rays and the other one are the neutrons. The gamma rays are radiation and they are attenuated by high density materials. So sometimes the concrete is used in order to the radiation, gamma radiation shielding using heavy aggregates. So one opportunity for the siderurgical aggregates could be the use in concrete for radiation shielding. So in this project we are going to check these properties of the material in order to demonstrate if it is possible or not use this material to prevent radiation shielding. In order to characterize the aggregates, we have performed tests for obtaining the chemical composition, X-ray fluorescence. We have obtained the crystalline structure by X-ray diffraction, also the physical properties, the sun equivalent, the radding, the shape index of the material, fleckness index, also the crushing value. This is a very interesting test in order to know how is the mechanical behavior of the aggregates, and also the Los Angeles test in order to obtain the Los Angeles coefficient. What about the properties of the fresh and hardened concrete? First, for the fresh concrete, we determine the workability using the Abrams cone for determining the slump. Also, it was determined the air content of the material. For the hardened concrete, the splitting tensile test, elastic modulus, of course, flexural strength of the material, the compressive strength of the concrete, in this case using cubic samples, and also the physical properties, the density, the porosity, and the absorption of the siderurgical aggregate concrete. Other tests performed on hardened concrete was the adherence and residual flexural test. In this case, we use cores in pre-stressed cores in order to determine the adherence of the siderurgical aggregate concrete. And also, we determine the flexural strength using 3 points and analyzing how is the fissure opening. What about the durability of the material? In this case, the carbonation was determined by the test of accelerated carbonation tests. Also, the chlorine diffusion coefficient was determined using special atmospheres for its diffusion. And also, the drying shrinkage was determined, in this case, in the Instituto Superior Técnico in Lisbon, and also the durability accelerated carbonation test was obtained in the University of Burgos. Other durability tests performed on the siderurgical aggregate concrete was the freezing thawing test performed in the University of Oviedo. Also, the behavior of the concrete exposed to high temperatures was analyzed. Also, oxygen permeability of the concrete was determined, the ultrasound pulse velocity, the water penetration inside this material, and also it was analyzed the material after exposition to marine environment. Also, another interesting research inside this research is to analyze the recycled aggregate concrete obtained using recycled aggregates coming from siderurgical aggregate concrete. Let me explain that. If we are right, in the future, we are going to have siderurgical aggregate concrete everywhere, maybe. And in the future, it will be necessary to recycle this siderurgical aggregate concrete. So in this project, we analyze how are the properties of the recycled aggregate concrete performed using recycled aggregate coming from siderurgical aggregate concrete. Let's see. Let's see now what are the properties of the siderurgical aggregates with the results of this project. In this picture, you can see different size of the material, 0.4, this is in millimeters, 0.20, 4.8, 8, 16. And in this table, the X-ray fluorescence of the material, so the chemical compositions in oxides. What is the main component of the siderurgical aggregate? You can see here that the iron is the most important component in weight of its composition. It is logical because it comes from the steel production. In this slide, the mixed proportions are presented. You can see that we have prepared 4 different mixed proportions and all of them with the same volume of aggregates. The first one is the standard concrete in order to compare the properties of the other different materials, other different concretes. The second one is a concrete in which we have changed the natural coarse aggregate by siderurgical aggregates. The third one is a concrete in which we have changed the coarse natural aggregates by recycled, The third one is a concrete in which we have performed a substitution of the natural aggregate by siderurgical aggregate in the coarse fraction, but also in the sand. Why and how? Here, in this case, it was necessary to crush the siderurgical aggregate in order to obtain a sand similar to the natural sand used in the first mixed proportions. And the fourth one, the fourth mixed proportion, is the one that is typically used to radiation shielding using magnetic material. Here, the physical properties of the material are presented. What are the density of the different materials? Okay, the density of the standard concrete is around 2.3, 2.5, depending on the density that we analyze. This is the apparent density, 2.5 grams by cubic centimeter is the typical value for the concrete. But if we incorporate the coarse aggregate to the concrete, But in the case in which we incorporate siderurgical aggregate to the concrete in the coarse fraction, we can increase the density, the apparent density, to 3.14. And also, if we incorporate not only the coarse aggregate, but also the sand in siderurgical material, we can obtain 3.5, around 3.5 grams by cubic centimeter. This is a very high density for a concrete. And the typical density, if we obtain concrete using magnetit is a natural aggregate typical for the radiation shielding in concrete, the density is near 4.3. Okay, this density is much higher than the density that we obtain with the siderurgical aggregate, but it is 3.5 maybe enough to the radiation shielding of the material. And why are here we planning to use this material to prevent the radiation? Because this is a waste. It was a waste. Now it's a siderurgical aggregate. And the price of the magnetit in order to produce radiation shielding concrete is very, very, very high. So let's try to use siderurgical aggregate because they are very cheap if we compare them with the natural magnetit aggregate. What about the mechanical properties? Remember that we are using a little bit more than 300 kilo by cubic meter of cement, in this case cement type 1, Portland cement, and the compressive strength of the control concrete, in this case, is very high. It's not low. It's 62 megapascals. But if we incorporate coarse aggregate, coarse siderurgical aggregate to this concrete, we can increase the compressive strength near to 90 megapascals. This is a high performance concrete. And also, if we incorporate not only the coarse aggregate, the coarse siderurgical aggregate, but the sand with using siderurgical crushed siderurgical aggregate, we can increase the compressive strength more than 100 megapascals. This is very, very, very good concrete. Also, the elastic modulus is very high. In this case, in the total siderurgical aggregate concrete, the modulus of elasticity is near to 60 gigapascals. And also, we can increase the flexural strength. Here in the pictures, you can see how is the material after testing. All of these results are obtained at 28 days. Okay. In this slide, you can see the result of the marine exposition of the material after 90 days and 220 days. In this case, we expose directly to the marine environment test cylinder, and also in this case you can see a cone in order to analyze different distances between the steel bar and the surface of the concrete. So to finish, let me read the conclusions. The shape and stiffness of the siderurgical aggregates improves mechanical properties of concrete, especially compressive strength and elastic modulus, when comparing to natural aggregates. The concrete with siderurgical aggregates show a higher concrete reinforcement bond due to its rawness and irregular shape. For all the durability tests, similar results were obtained for natural and siderurgical aggregates. For recycled aggregate concrete, similar compressive strength and splitting tensile strength were achieved for all replacement, showing good bond between recycled aggregates and the new paste. And thank you very much for attending. Here you can find my email and my webpage, also the LADICIN webpage, the Laboratory of Materials of the University of Cantabria. Thank you very much.